tinatawag na position. Ayan. Position. Okay? May kinalaman ito sa vectors kasi ang position ay yung parang pag-describe mo sa isang particle or object sa space. Okay? Sa free space. So, halimbawa, meron akong x and y plane. X and y plane. Tapos, number yan. Na, halimbawa, ito ay 1, 2, 3. Tapos, 1, 2. Tapos, meron akong point P. So, if I'll ask you, what is the position of point P? So, magiging position ng point P, syempre, para ma-describe mo yung position niya, kailangan mo ng reference. In this case, ang nagiging reference natin yung x and y plane. Kaya pwede nating sabihin na ang position ng point P ay nasa 3, 2, na yung x along the x component, x-axis ay positive 3 at along sa y-axis is positive 2. Kaya ang position niya ay ganyan. Kaya napaka-importante ng mga references sa pag-aaral ng kinematics. Particularly, pag dinidescribe natin yung position or location ng isang bagay or particle. So, halimbawa, sa one dimension kasi, unang-unang pinag-aaralan yung horizontal lang. So, halimbawa, meron akong poste dito. Okay, so tapos, meron akong isang tao dito. So, if I'll ask you, what is the position of the person? So, kung wala kang masasabing reference or value, syempre hindi mo rin madidescribe yung position ng tao. Okay, so kung ganon, hindi natin madidescribe yung position niya kasi wala tayong sinasabing reference. Pero halimbawa, ito ay ginawa nating reference tapos may layo siya na let's say it's 3 meters. So if I'll ask you again, so what is the position of the person? So pwede na nating sabihin it's 3 meters from the left of the post. Tama ba? 3 meters left of the post. So pwede nating i-describe siya, kumpleto na information, na yung position niya ay nasa 3 meters left or west nung post. Okay? Kaya pag dinidescribe natin ng position, we always need a reference. Okay? Kailangan natin ng reference para ma-describe yung position. Parang halimbawa, di ba kung nagda-drive kayo tapos may nakikita kayong number sa highway, ang sabi nila, ang reference dun is yung Luneta. Yung parang yung 0 kilometer yung kay Rizal. At yun yung parang nagiging reference sa buong Pilipinas. Kung meron kang nakikitang mark doon sa daan, yung number na yon is naka-refer siya sa Luneta. Ayun yung parang nagiging reference. Ayan. So, yun yung first quantity na pinag-aaralan sa kinematics, yung position. Siyempre, yung position, so meron siyang kinalamang sa length at ang nagiging unit natin, it's either meter or foot. Okay? So, those are the two standard quantities. Yung meter ay para sa SI, tapos yung foot para sa English. Ayan. Okay? May question on the first quantity?
Parang wala naman po, sir.
Okay, wala. Sige. So, ang next natin ay yung average velocity at saka average speed. Ayan. So, bago natin pag-aralan ang average speed and average velocity, kasi kailangan muna natin i-differentiate ano ang distance at saka displacement. Okay? Ano ba ang distance at saka displacement? Kung meron akong dalawang point dito, let's say this is point A, tapos nandito yung point B, at yung path taken ng ating particle na mag-move from point A to point B ay dalawa. So let's say this is path 1 and this is yung dark na, yung heavy na line will be path 2. Ayan. Path 1 yung broken line and then yung path 2 yung yung heavy line. Tama ako. O yun. Kaya yung particle natin or yung object ay nagsimula siya sa B, A, at meron siyang dalawang path to take. Yung isa ay nandito sa broken line para makapunta siya sa B. Yung isa naman ay didiretso siya sa from A going to B. Ayan. So if I will ask you, alin sa dalawa yung magpapapoll ako. Okay, alin sa dalawa ang distance? Path 1 or path 2? Distance. Class, yung hindi ko na inaano yung sa module natin kasi ayan, kayo nang bahalang magbasa nun or manood nung sa module natin. So, tinatry ko na lang siyang i-discuss ng ayan. Path 1. May about yung iba, Hazel, Hans, Catherine, Kingdon, Mark, Joshua, Joshua, Mary, Nicholas, Paulo, Vincent. How about you? What do you think? Okay, so ang sumagot ng papublish ko na lang yung poll natin. So meron pang hindi sumagot na dalawa. Ayan, si Vincent na lang. Vincent? But anyway, so ito na yung sagot. And na yung result ng poll natin. Okay, 48% said it's path 1 and 39% said it's path 2. Okay, class. Ang distance is the total path taken. Okay, and displacement is the shortest path. Okay, regardless kung anong mangyari, ang displacement is the shortest path. That means that's the direct path from point A to point B. So majority got it correctly. Ito yung distance natin, and this is the shortest path, and this is the displacement. Okay? Total path taken, kung ano yung length ng tinake ng particle to move from point A to point B, that is the distance or the distance. And then yung displacement is always the shortest path directly from point A or the initial position going to the final position. So that is the displacement. Okay, because also distance is a scalar quantity. Okay, and displacement is a vector quantity. So that means apart from the magnitude or the total length, it has a direction. Okay, what does it make? Why does it make it also a vector o yung displacement natin? Isa din kasing characteristic para sabihin mo na vector ang isang quantity at any point in the path daw dapat pare-pareho yung direction. Okay, pare-pareho yung direction. So halimbawa, nandito yung particle natin. Tapos, okay, halimbawa, nandito yung particle. Pag pupunta siya sa point B, it will follow this direction. Pag nandito na siya, it will also follow this direction. So that means at any point in the path taken by the object, the direction does not change. So that makes it a vector. So unlike dito, pag dito yung path taken, so halimbawa, nandito yung particle, ang direction kasi ng speed, yung velocity niya, is always tangent to the path taken. So that means, so nandito yung direction niya. Pag nandito naman yung particle natin, nagiging ganito yung direction. Pag nandito naman siya, ito yung nagiging direction. So sa path taken ng ating distance, yung direction ng particle natin nagbabago depende kung nasaan siya. That's why hindi mo ma-identify kung ano yung iisang direction niya, kaya hindi siya pwedeng tawaging vector. Okay? So yun yung distance. So yung total path taken. Yung displacement naman, yun yung path mula dun sa initial point going to the final position. Okay? Okay, so let's have an example. Meron isang swimmer. Okay? So merong swimmer, so magsiswimming siya sa isang pool na 50 meters yung length. Okay? So yung length ng pool ay 50 meters. Yan, ito ay point A, tapos ito yung point B. So yung swimmer natin ay, siyempre magsiswimming siya, mula dito hanggang dito. Okay, so that's path A to B. Tapos babalik siya ng B to A. Ayan. So yung track niya ay mula A to B, tapos babalik siya from B to A. So ang tanong ay, letter A, ano yung total distance traveled? Ano yung shortest distance? Shortest distance. Ano yung total distance traveled ng swimmer?
100 meters, sir.
Okay, so tama ka. It's 100 meters. So that is the total path taken. Okay? How about B? What's the displacement?
Displacement po is 50 meters ata po.
Ha? Displacement is?
50 meters po.
50 meters. Nasaan siya initially? Point?
Initially, as in simula po. Sa 0 meters po.
Okay. Saan siya natapos?
Same position din po.
Okay. So, ano na ngayon ang displacement? Okay. So, ang sagot ay, tama si Justin at saka si Angelo. Ang sagot ay 0. Kasi bumalik siya sa initial position niya. So that means, from yung start, nandun siya, yung end, nandun siya, so walang displacement. Yeah. Okay? Meron din tayong formula for displacement. Ang formula kasi natin sa displacement is final position or x final minus x initial. Okay. Or initial position. So final position, initial position. Di ba, nasabi ko kanina, pag position ng pinag-uusapan, dapat meron kang reference. Okay? Pag position ng pinag-uusapan, dapat may reference. Ano yung reference? So ang reference kasi ay, syempre ikaw magsiset. So halimbawa, ang reference natin ay A. So dapat isiset mo yung A as 0 distance or 0 position. 0 meter, 0 position. Kung reference natin ay A, ano ang X initial? So anong position niya with that reference? Di ba since nandun siya, so ang reference mo ngayon ay yung initial position mo ay 0. Ano yung kanyang final position? Di ba bumalik siya sa A, which is also 0. Kaya, ang displacement niya ay 0 minus 0, which is also 0. Okay? So, alimbawa naman, nilipat ko yung reference niya sa B. Ano ang magiging x initial? Kung itong reference natin, so that means this is 0 meter. Nung initially, nasa A siya, ano yung position niya with respect to B? Kung B yung reference natin, ano yung position ng swimmer initially with respect to B? Parang yung kanina, i-describe nyo ano yung position ng swimmer with respect to B. Okay, Michael. So it should be negative 50 meters kasi nasa left siya nung B na may layo na 50 meters. Ano naman ang kanyang x final? Simula siya sa A, nag-swimming siya papuntang B, bumalik siya sa A. So
Positive
yung
50.
negative 50 din. So therefore, yung displacement niya ay negative 50 minus negative 50, which is also 0. Kaya kahit saan mo pa ilagay yung reference, pinag-uusapan lang naman, reference din naman yun eh. Para lang ma-describe mo kasi yung position niya. Okay? May question ba? Sige. So meron akong magte-test tayo ng konti. Okay. So meron akong figure na ipapakita. And then you'll tell me the distance and the displacement. Okay? Yan. So, magsusulat ako. You tell me the distance and the displacement. Okay. So, dito sa figure na yan, ito yung path taken ng particle natin. So, at 0 time, at time is equal to 0, nandito siya sa position 1 meter. So, ito yung reference natin na number line, na horizontal number line. Nandito yung 0, tapos nandito yung mga position niya. Okay, 1 meter, 2 meters, 3, and so on. Kasi positive sila to the right of 0. And then yung sa left ng 0, mga negative. At ito yung path taken ng object natin. At 0 time, nasa 1 meter siya. At 1 second, after 1 second, nasa 3 meters siya. At 4 seconds, at 2 seconds, nasa 4 meters siya. After 3 seconds, so nasa 2 meters. And then 4 seconds, nasa negative 1 meter. Ayan. Okay? Ang question ay, example to. Okay, ano ang from 0 second to 4 seconds? Ano ang total distance travel? Okay? Next, ano ang displacement? So this is how you will differentiate displacement from distance. From 0 second to 4 seconds, ano yung total distance traveled at ano ang displacement? Parang hindi natatapos yung na-type mo, Angelo. Okay, so ang sabi ni, ang distance ay negative 2 meters and displacement is 9 meters. Di ba baliktad? Hindi, naisip ko lang. Okay. Do not do not mix up the two. Distance is the total path taken. Displacement is the shortest path. The direct path. Okay, tama. Tama na yan. Angelo, tama na ba yan? Final answer. Okay, distance is 8 meters. And sabi niya, and displacement is -2 meters. Okay. Sandali, may nagtatype kanina si ano. May sumasagot din ba siya? Si Justin? Okay. Okay, ngayon, di-discuss natin. O sige, sabi nilang dalawa, 8 meters is distance. Remember, distance is the total traveled path taken. Kasi nagsimula siya dito. So, bibilangin na lang natin. So, at 4 seconds. So, nagpunta siya dito, 1. Tapos, 2. Tapos, 3. Okay? Tapos, bumalik siya, 4. And then, 5. Then, 6. Then, 7. And then, 8. So, therefore, so tama sila, it's 8 meters. Yeah. Okay. Next, how about displacement? Class, displacement is x final minus x initial. So, what is x initial? Okay, nasan siya at initial? 0 seconds. So, nasa 1 meter siya. Okay, nung final position at 4 seconds, nasa -1 na siya. So therefore, displacement is equal to -1 minus 1, which is -2 meters. So tama din sila, -2 meters. Or kung gusto mo siyang i-manual, pwede din. Nandito siya, pumunta siya doon. So pumunta siya dito. So bilangin mo lang, 1, 2. Kaya lang ang direction niya is to the left, kaya siya naging -2. Kasi it's the shortest path taken. Kuha nyo ba?
Yes po, sir. Nagets ko na.
Nagets na? Sige. So, let's have another one. So, what if it's 0 second to 3 seconds? So, what is the distance and what is the displacement? From 0 to 3 seconds.
Sir, yung distance po is 6 meters po.
6 meters. So, 1, 2, 3. Bilangin natin. Diba? 1, 2, 3, 4, and 5. So, yung pakanan niya, tinravel lang niya is 3 meters. Plus, nagkumaliwa siya na 2 meters. Kaya ang total ay 5 meters. Diba nag-travel siyang kanan, 3. 1, 2, 3. Tapos, nung nandito na siya, nag-travel siya pabalik ng 2. 1, 2. Kaya, naging 5 meters. 3 plus 2 equals 5.
Sorry, sir. Nag-start po ako kasi ng 0 eh.
Inano mo as 1 yung 0. No. Okay. Yung initial lang niya, that's the position. Kaya lang ang inaano natin is total path taken. So, kahit nasa 1 siya, it will act as 0 distance pa rin. Nakuha mo ba? 0 distance pa rin. Kaya doon ka pa rin magsisimula. So, kung habang nagta-travel siya, ito ay 0 pa rin. So, ito ngayon ay magiging 1 meter, 2 meters, 3 meters, 4 meters, and then 5 meters. Okay? So, how about the displacement? Okay. Okay, so displacement daw ay 1 meter na positive. Tama ba ako, Angelo? Positive yan, di naman negative yan, no? Okay. So, okay. Kung hindi kayo sigurado, pwede naman natin siyang idaan sa formula. Diba? Ano yung x initial natin? So, x initial 0 pa rin and that is at 1 meter position. Okay? Ano yung x final? Okay? X final is at 3 seconds. Ano yung position niya at 3 seconds? It is 2 meters. So, therefore, displacement is equal to 2 minus 1 or 1 meter. So, positive means it's going to the right. Okay. So, let's add the last one. Ito, last na to. From 1 second to 4 seconds. So, what's the distance and what is the displacement? Ayan. From 1 second to 4 seconds. So, ang magiging initial nyo niyan is yung 1 second. Kung nasaan siya at 1 second. So, that will be the initial position. Kung nasaan siya at 1 second. Okay, final position is kung nasaan siya at 4 seconds. Initial niya, 1 second. So, doon kayo magsisimula 0 kung nasaan siya at 1 second. And then, final position niya is at 4 seconds.
Sir, question lang. Bakit hindi po siya yung start initial po tsaka final position po 0 to 3 seconds?
Babalik tayo sa B.
Yung din sa displacement po, yung hinahanap yung displacement ng 3 seconds po. Ba't di po kasi 0 to 3 siya?
Sandali. Dito, letter B ba tayo? Letter B ba ang tinatanong mo?
Wait lang, sir. Opo, sir.
Okay, ano yan? Ang question dun sa B?
Yung displacement po, bakit di po siya 0 to 3 seconds?
Tama. Yun yung time. Time kasi. Time yun. Yung reference natin yung time from 0 to 3 seconds. Nasaan ngayon ang pag-uusapan natin pag displacement na at saka distance kung nasaan sila initial hanggang papunta dun sa final time. Kaya reference
Okay.
lang natin yung time.
Okay po.
Time lang yon. Mamaya kasi kaya inaano ko yon. Pag nagpunta tayo sa speed at saka sa velocity, kailangan natin yung time. Kasi babalik tayo dito sa example na to pag nagpunta na tayo sa average velocity and speed.
Okay po, sir. Okay po.
Ngayon, inaano lang natin paano kumuha ng displacement at saka distance. Okay? So, ang sabi ni Justin, distance daw ay 6 meters. So, if you will count, so 1 second tayo papunta doon. Mula dito papunta doon. So, ito niya yung magiging 1, 2, 3, 4, 5, and 6. So, tama siya. Na ang 1, meron tayong 1 meter na pakanan plus 5 meters na pakaliwa. So, meron tayong 6 meters. Okay? Ang displacement naman ay negative 4 daw. Kasi, if we will follow again the formula, ano yung x initial? So, at 1 second, nasaan siya? Di ba? Nasa 3 meters. At 4 seconds, nasa negative 1 meter. Kaya kung apply natin to, ito ay negative 1 minus 3 or negative 4 meters. Ayan. So, tama si Justin. Negative 4 meters. Negative means it's going to the left. Kasi di ba, dito, shortest path, papunta dito. So, bibilang 1, 2, 3, 4. To the left. Ayan. Okay? Okay, so yun yung difference ng displacement at saka distance. Ang displacement ay pwede siyang mag-positive or negative, which means, or which denotes direction. Ang distance is lagi siyang positive. Kasi, ayun, walang negative distance. Okay. Okay, babalik na tayo sa average velocity and then average speed. Okay. Pag sinabing average ito, speed, so kailangan ang symbol natin na average, Sam, okay lang Sam. Ayan. So, average speed, pag pinag-uusapan natin ay average, so dapat meron siyang subscript na average. So, speed is average. So, ang formula natin dyan is distance over yung total time to cover that distance. So, ito ay distance over the total time para ma-cover yung distance. Okay? At yun sa average velocity, so shortcut ko na lang yung average. Ayan. So ang symbol niya is yung V, dapat meron siyang word na or subscript na average. Ito naman ay yung displacement over yung time niya. So that's equal to x final minus x initial over t final minus t initial. So this is displacement over the total time to cover that displacement. Okay? Total time to cover that displacement. So, ayan. Average speed, that's the total distance over the total time to cover that distance. And yung average velocity is the total displacement over the total time to cover that displacement. Okay. May question? So, let's go to this example. Yung example nating swimmer. Okay, kung babalik tayo sa example ng swimmer, okay, if I'll ask you, letter A, what is the, letter C na, what is the average speed? What is the average speed of the swimmer? Okay, so what's our formula? Sorry, wala palang time. Halimbawa, kinover niya in 20 seconds. So, natapos siya in 20 seconds. So, swimming siya ng from A to B and B to A ng 20 seconds. So, what is the average speed? Formula natin is D over T. So, that's equal to what's the total distance traveled? So, that's 100 meters. And the total time to cover is 20 seconds. So, therefore, the average speed is 5 meters per second. Okay? 5 meters per second. So how about the average velocity? So D, what is the average velocity? Okay, so sabi natin, average velocity is displacement over time. So that's equal to displacement over the total time. Okay, ano ba ang displacement niya? Na-compute natin. Diba ang displacement niya ay 0 and time is 20 seconds. So therefore, V average is equal to 0 meter per second. Ayan. Okay, V average velocity is 0. May question?
Sir, parang klaro naman lahat po.
Okay. So, si Charles may sasabihin yata. Charles, itatanong ko ba, Charles? Tandaan nyo lang, average speed is distance over time. And then, average velocity is displacement over time. Okay. So let's go back to the figure earlier. Yeah. Same naman yung tatanong ko. Average speed and average velocity. Yan. So babalik tayo dito. Nakita nyo ba yung figure? Hindi. Yan. So babalik tayo. Okay. Saan na yun? Nasaan na yung sinula ko? Sa letter A, what is the average speed and the average velocity? From 0 to 4 seconds, so what is the average speed and the average velocity? Okay, so ano ba yung total distance? Total distance is 8 meters, and then yung total time to cover is 4 minus 0. So that is 4 seconds. So the answer is 2 meters per second. Okay, how about the average velocity? Average velocity, ano yung displacement? It's negative 2 meters, and then the time is 4 seconds. So the answer is negative 0.5 meters per second. Tama? Okay, how about this one? Yeah, kayong sumagot. S average. So what is the average speed of from 0 to 3 seconds? Ayan. So that's distance over time. So that's 5 meters over 3 seconds. Ay, hindi ko alam. Ano yung 5 over 3? 5 divided by 3. 1.67 meters per second. And then the average velocity is displacement over time. So that's equal to 1 meter over 3 minus 0. Or 1/3. Or point, tama ba ako? 1 ba siya? Okay, 1 over 3. Okay, so 1 over 3. Or that's a 0.33 meters per second. Ayan. Okay, so let's change it. Para naman ano. Ayan. Let's have another one. D. Based on the figure, what is from 2 to 4 seconds, what is the average speed? And then the average velocity. Okay, based on the figure, from 2 to 4 seconds, what is the average speed and the average velocity?
Sir, may problema lang po dyan dun sa problem. Kulang po siya ng distance.
Yun yung hahanapin.
Okay po, sir.
Dun sa figure, so formula natin is D over T. So yung time natin is 4 seconds minus 2 seconds. Ngayon, ano yung distance? From 2 to 4 seconds. So refer to the figure to identify the distance. Okay, from 2 to 4. 2 to 4. So, ano distance from 2 to 4? Okay, 5 meters sabi ni Justin. Tama ba? So, 5 meters. So, magiging 1. Mula ka dito, 1, 2, 3, 4, and 5. So, 5 meters. So, that's 5 over 2, 2.5. So, 2.5 meters per second. So, tama ka. How about the average velocity? Okay, how about the average velocity? So average velocity is displacement over time. Okay, so displacement over time. So that's equal to, or that's x final minus x initial over t final minus t initial. So that's equal to, ano yung x final natin? Ano yung position niya after 4 seconds? It's negative 1 minus, ano yung initial position niya at 2 seconds? It's 4 meters over 4 minus 2. So that's equal to, tama ba ako? Negative 4. Negative 1 at past. O, tama. Tama na. It's negative. Okay, it's just negative 2.5 meters per second. So negative kasi it's to the left. Ayan. Okay. Nagkataon na same yung distance at saka displacement. Okay, so that's the only way na pwedeng yung distance actually at saka yung displacement. At some point, pwede naman silang magpareho. Kasi kung wala naman ibang path to take, kundi yung diretso lang. So that means, pareho lang sila ng magnitude. So pareho yung haba ng distance at saka ng displacement. So yun lang yung time na pwede silang magpareho. Pero syempre, dahil vector yung displacement, meron siyang direction. Pwede siyang maging positive or negative. Pero yung distance, dahil scalar siya, hindi siya pwedeng magkaroon ng direction or hindi siya pwedeng magkaroon ng sign na lalo na kung negative. Okay? Okay, so yan ang average speed at saka average velocity. Because we'll proceed to the next type, yung tinatawag na instantaneous velocity. Okay, class. Okay, may question ba kayo dun sa
Klaro lahat naman po, sir. No questions po, sir.
Okay, sige. Let's proceed to the next one. Okay, yung instantaneous velocity. So, ito yung formula ng instantaneous velocity. Okay, instantaneous velocity is the average velocity as the limit of delta t approaches 0. Okay, class, dito na tayo magka-calculus. Calculus part na to. Parang ang limit daw, nililimit niya yung average doon sa time na parang pinapalit niya yung time na hindi naman equal sa 0 yung time, pero it approaches 0. Kaya siya dito na yung limit ng average velocity as the limit of delta t approaches 0. Pero in short lang class, if we have the equation of the position, which is x, so that means just get the first derivative of the position, you will have the velocity, instantaneous velocity. So ito, we can express this as the first derivative of the equation of the position. Okay, first derivative of the equation of position. Okay, ngayon, ano bang ibig sabihin ng instantaneous? Pangalan pa lang, siyempre, it's an instant. Okay, yung average kasi, yung average velocity kasi, ayan, ang kino-consider lang ng average velocity is yung initial at saka final. So, halimbawa, di ba? Kasi ang formula natin sa average velocity ay equal siya sa delta x over delta t na x final minus x initial over t final minus t initial. So, halimbawa, mula dito hanggang dito, ayan, ito yung ating displacement. Ayan. Point A to point B. Ang average, ang tinitignan niya kasi is yung initial and final. kung anong nangyayari dun sa gitna, na nangyayari sa motion sa pagitan ng dalawang point na to, hindi yun nakikita ng average. Ang tinitignan kasi lang ng average is yung initial and final. So, halimbawa, yung total distance, yung total path na to ng displacement natin is 100 kilometers. Tapos, kung nagta-travel ka, halimbawa, mula dito hanggang dito, tinravel mo lang siya ng 4 hours. Tapos, bigla kang nagpahinga ka ng 2 hours. Tapos, nag-travel ka naman, nagpunta ka dito ng 8 hours. Tapos, nagpahinga ka ng 1 hour. Tapos, nag-travel ka ulit, natapos mo siya in 5 hours. Ayan. Ano yung average velocity mo? So, ang average velocity mo, syempre, yung displacement natin is still, displacement natin is still 100 kilometers. Pero yung time natin is i-cover natin lahat kasi that is the total time na kinover niya yung path taken. So, halimbawa ito ay 5, 10, 20 hours. So, ang average velocity mo ay naging 5 kilometers per hour. 5 kilometers per hour. Parang ang bagal, no? 5 kilometers per hour. Sobrang bagal naman. Anyway, ang point lang dito ay ang average velocity, hindi niya tinitignan kung anong nangyayari dun sa path taken. Ang tinitignan ng average velocity is kung ano lang yung initial at saka final. At saka yung total time na kinover mo yung distance mula initial hanggang final. O yung displacement mula initial hanggang final. Kaya yun yung sa average. Ang tinitignan ng instantaneous, kaya siya tinawag na instantaneous, that instant or point in the path taken, kung ano yung velocity niya, yun yung instantaneous. So, halimbawa, kung nagta-travel kayo, nagmamaneho kayo, tapos napatingin kayo dun sa speedometer nung sasakyan ninyo, kung anong reading ng speedometer, that is the instantaneous value. At that instant na nakita mo kung anong reading ng speedometer, that is the instantaneous value. At that particular instance. Ayan yung role kasi ng velocity calculus. Tinatry niyang palitin nyo para maging siyang accurate. Okay. Nakuha nyo ba ang ibig ko sabihin? Average, it only deals with initial and final. Instantaneous, yung paunti-unting motion ng object mula initial hanggang final, yun yung tinitignan niya. At yun yung kanyang nakikita. Okay? So one more thing, class. Tingnan niyo yung symbol ng instantaneous velocity. Okay, pag sinabi nating velocity, automatic, pinag-uusapan natin ay instantaneous value. Hindi natin kailangan sabihin na instantaneous velocity para sabihin nating instantaneous velocity yung pinag-uusapan. Automatic, pag sinabi nating velocity, instantaneous value na yung pinag-uusapan. Pero pag pinag-uusapan natin ay average, kailangan yung i-attach yung word na average. Kaya nga siya V subscript average. Kailangan yung i-attach yung word na average para ibig sabihin natin nun is average. Pero pag sinabi nating velocity, automatic, pinag-uusapan natin ay yung instantaneous value. Ganon din sa acceleration at saka sa speed. Pag sinabi kong speed, pag sinabi nating acceleration, automatic, ang pinag-uusapan natin ay instantaneous value. Kung pag-uusapan natin ay average, kailangan i-attach nyo yung word na average, like average speed, average velocity, or average acceleration. Pero pag velocity lang sinabi natin, speed or acceleration, automatic yon na ang pinag-uusapan natin ay instantaneous. Okay? Ngayon, ano naman ang relation ng speed sa velocity? Or anong relation ng instantaneous speed sa instantaneous velocity? Ang speed is the magnitude of the the instantaneous velocity. Okay, class. Para makuha natin ang speed, kailangan natin yung velocity. Okay? Ang tawag sa magnitude ng velocity ay speed. Ayun lang sila nagkakaroon ng relationship. Ang instantaneous speed at saka instantaneous velocity, meron silang relation. Ang relation nila ay ang tawag, ang magnitude ng instantaneous velocity, yun yung instantaneous speed. Wala lang siyang direction. Kaya pag nakuha mo na ang velocity at meron kang nakuhang value, yung value na yon, kung yan lang yung consider mo, yun yung speed. Kaya instantaneous speed is the magnitude of the instantaneous velocity. Wala lang siyang direction. Pero yung average speed at saka average velocity, wala silang relation. Wala. Pero ang instantaneous velocity at saka instantaneous speed, meron silang relation. Ang relation nila ay, ang tawag sa magnitude ng instantaneous velocity ay instantaneous speed. Or just simply speed. Okay, so I think that's it for today. So next meeting, on Wednesday, we will solve problems involving instantaneous velocity and instantaneous speed. So, class, medyo kailangan nyo nang mag-review ng calculus dahil magdi-diff-cal tayo sa examples na to. Magdi-derivative tayo. Magdi-diff-cal, differential calculus tayo, tsaka integral calculus pagdating natin dito sa example ng instantaneous velocity. Same true is with instantaneous acceleration. Derivative. Mga simpleng derivative lang naman. Simpleng derivative lang naman. Okay? So, kung wala na yung questions, so that's it for tonight. So, good night.
Thank you po, sir.